Hello guys, welcome to my channel. In this video, we will see some sample questions for upcoming VIZAGSTEEL exam. So let's start. The first question is to find the Thevenin equivalent resistance practical independent sources are replaced by. So it is saying about the practical independent sources. The option is current source by open circuit and then voltage source by short circuit. The second option is voltage source by open circuit and the current source by short circuit. The third option is by their internal impedance. And the last option is both can be either short circuit or open circuit. The answer will be C option by their internal impedance. So let's see next question. A sluggish system can be made faster. So a sluggish system, a slower system can be made faster by increasing the damping, decreasing the gain, increasing the gain, and adding lag capacitor. So here it is talking about the K, whether increasing or decreasing. The answer will be C option, because as the system gain increases, the damping decreases and the slower system becomes faster. As K increases, system becomes faster. So, but it should be done within the limits. So C option is the right answer. So let's see the next question. Here it is given the characteristics equation as 4 plus ASQ plus S square plus BS plus 1 equal to 0, where A and B are real values. So it is asking for the stable system, what is the relation between A and B. So these are the options it has given. So we have to find the RS table. We have to form the RS table first. If you form the RS table, it will be like this. And if you take the first column elements to be positive, all to be positive, these two conditions you will get: A minus B greater than 0 and A square plus B less than AB, which is not possible. These two equation has no solution, so it is not possible, so it is always unstable. So A square plus B less than AB is one of the, here you can see A square plus B less than AB is one of the options, but we have to see both equations, these both equations. So no condition can satisfy for the stable system, so it is unstable. So the last option D is correct. Next question, it is saying a transformer designed for the operation of 50 Hz now is working on 60 Hz supply without changing its voltage and current rating. When compared with full load efficiency at 50 Hz, the transformer efficiency at 60 Hz will be. So it is saying what is the efficiency compared to the 50 Hz operation if the transformer is operating on 60 Hz. So these are the options. As we know, eddy current loss is proportional to V square and hysteresis loss is inversely proportional to F to the power 0.6. So as F increases, P will also increase. The pH, hysteresis loss also will increase and the core loss will increase. This means if you increase the frequency, loss will be increasing. If the loss will be increasing, efficiency will decrease. So the last option is the right answer. Next question, it is saying the following statement regarding high voltage transmission. With the increase in voltage, insulation required between the conductors and the earth tower increases. Second, it is saying transmission efficiency decreases with the increase in transmission voltage. Third option, it is saying voltage regulation decreased with a high voltage transmission. So we know that in high voltage transmission, transmission efficiency increases due to reduction in the line losses, and high voltage leads to better voltage regulation. So the first option is only correct. The first statement is only correct. It is asking about the which of the statement are correct, so you have to choose the first option, first statement only. Next, it is saying about the bundle conductors. So it is saying bundle conductors reduce corona loss in an EHV line because these are the statements given. The first statement, it is saying inductive reactance of the bundle conductor is increased. Inductive reactance means XL. It is saying XL is increased. Next, it is saying self GMD of the conductor is increased. Next, it is saying critical disruptive voltage is decreased. So, what will the correct answer? So, if you see the bundle conductor, it reduces inductive reactance, not increases inductive reactance, and increases the self GMD. So, the only second option, second statement is right. So, let's see the next question. Consider the following statement. It is saying MOSFET can be used as a current controlled capacitor and resistor, but we know that MOSFET can be used as voltage control, not current control. So first option is wrong. In an N-channel E-MOSFET, threshold voltage can be lowered by increasing the substrate doping concentration. So we know that by increasing substrate doping concentration, threshold voltage increases. So neither of the options are correct. So the last option is right. Let's see the next question. Here 3 bulbs are connected like this to a 3-volt battery as shown in figure. So it is saying the total current supplied by the battery is. So you can say we can add the powers of each bulb and we can calculate P total. So P total equal to 10 watt plus 15 watt plus 20 watt equal to 45 watt. So it is connected to a 3-volt source. So the net current will be P by V. P equal to 45, V equal to 3. So the answer will be 15 ampere. Last option. Next, it is asking the RMS value of the waveform. RMS value you can see the waveform is repeating after 8 seconds. So you have to calculate for 1 period the RMS. So we know that this is the formula for RMS. We have to square it. Then we have to take the mean value. Then we have to take the root value. So RMS means root of mean of squares. First you have to square, then you take the mean, then you have to calculate the root. So individually square it. 80 square is equal to 80 square. 80 square equal to 6400 into time period. This area into time period into T. Then this is 40 square minus 40 square. 40 square equal to 1600 and into T this time period into 2 And next is also 40 square. 40 square equal to 1600 into 2. This time period equal to 2. So if you add all this, you will get this 2400. And finally you have to divide by 8 also, because the time period is 8. From here to here the time period is 8. From here to here the time period is 8. So you have to divide it 8 also. So if you take the root over, it will come as 20 root 6. So the answer will be the B option. Next question, it has given two concentric spherical cell and carrying equal and opposite uniform charge Q distributed over their surfaces as shown in the figure. So this is plus Q and this is minus Q. This is R and 3R. So it is asking electric field on the surface of the inner cell. Inner cell, it is asking about the R. So we know that considering the Gaussian surface, just on the inner cell, electric field due to the charge is E equal to Q by 4 pi epsilon naught R square. This is the value of field. So you can say directly the electric field will be the B option, Q by 4 pi epsilon naught R square. Let's see the next question. The next question, it is saying approximate value of damping ratio. Damping ratio means zeta for the second order system to get the phase margin of 40 degree. So it is saying if the phase margin is 40 degree, what is the damping ratio? So this is the formula. Approximate formula is phase margin is equal to 100 into zeta. This is the approximate formula. So phase margin is given 40 and it is equal to 100 into zeta. So if you want to find zeta, zeta will be 40 by 100. So it will be 0.4. So the answer will be C option. Next, it has given two columns, you have to match them. So first column, it is proportional controller, second integral, then third derivative, then it is reset mode, anticipation error, offset. We know that proportional controller always keeps a offset error. So A will be third option. And integral controller is called the reset mode controller. And derivative controller is used for anticipation of error. So you can see A3, B1, C2, A3, B1, C2, C option, the right answer. So let's see the next question. It is saying in a p-type semiconductor, the acceptor density is 10 to the power 20 and the intrinsic concentration is this much. The value of electron concentration will be. So we know that Ne into acceptor into donor, you can say Nd is equal to Ni intrinsic concentration square. So if you put the values this value and this value here, we can calculate NEP. So it will come as 6.25 into 10 to the power 18. Last option will be the right answer. So let's see the next question. It is saying the torque of a DC separately excited motor operating under constant terminal voltage is related to its output power H under. So what is the relation between torque and power for a separately excited motor which is operating under constant terminal voltage? So you can say torque is proportional to Ia and P is proportional to Ia. So finally torque is proportional to P. So the B option is right answer. Next question, it has given Y-bus matrix of a 3-bus system in per unit, and it is asking which bus does not have shunt elements. Which bus does not have shunt elements? Here it is given the Y-bus matrix. You can see the concept behind in this question is the non-zero sum. If the sum is non-zero, sum of the row is non-zero, then shunt element is present. So it is asking which bus does not have shunt element. So you have to find which row elements adding to 0. So if you take the sum here, minus 13 plus 10 plus 5, it is non-zero, and minus 10 minus 18 plus 10 plus 10, it is also non-zero. And here if you'll see 5 plus 10, 15 minus 15, it is coming as 0. So here the shunt element is absent, so you can say 3 only. The last option is right answer. Let's see the next question. So it is saying about the Moore relay. It is saying in the first statement that Moore relay are more tolerance to arc resistance, has the more tolerance to arc resistance, and it is saying offset Moore relay can also see a close-up fault and a fault which lies behind the bus bar. And the third statement is saying when plotted on the impedance diagram is a circle centered at the origin. We know that Moore relay characteristics is like this, its center is not at the origin. So the third statement is wrong. 1 and 2 is correct. So C option will be the right answer. Let's see the next question. It has given at the open circuit as shown in the figure, and it is asking what is V0, V output. So if you see here, if you consider this as V plus, if you apply KCL here, you will get like this: V plus minus 10 by 60 plus V plus minus 15 by 20 plus V plus by 30 equal to 0. Finally you will get V plus as 55 by 6 volt. And if you apply the formula here, it is also V plus here. So V naught equal to 1 plus R2 by R1 V plus. Then finally we will get V naught as 55 volt. So the B option will be right answer. Next question, let's see. It is saying input output voltage specification for the standard TTL family are shown in are given as follows. So then it is saying the low level noise margin will be, so for the low level noise margin the concept is minimum minus minimum. So if you minus these two value, 2.2 minus 1.8, minimum minus minimum, 2.2 minus 1.8, it will be 0.4, which is for the low level noise margin. So the last option will be the answer. Next question, it has given a 2-pulse converter is feeding a constant load. The commutation angle is 60 degree for 0 degree firing angle. Then for 60 degree firing angle, the commutation angle will be. So we know that this is the relation between firing angle and commutation angle. Cos alpha is minus cos alpha plus mu equal to constant. So here alpha is the fanning angle and mu is the commutation angle. So if you put the condition, first condition, this alpha is equal to 0 and mu equal to 60 degree, you will get like this. And then if you will put for the second condition alpha is equal to 60 degree, you will get mu equal to 30 degree. So the answer will be B option. Next question, it is saying consider the following statements regarding static rammer drive. First statement, it is saying it offers speed control below synchronous speed only. Second statement, it is saying static rammer drive is a constant torque drive. Third, it is saying slip power is directly fed to the AC lines. Directly fed to the AC lines. This is incorrect because slip power is fed back to the AC lines through DC links, not directly. So third option is wrong. Only first and second statements are right. So A option is the right answer. So let's see next question. It is saying the feedback diodes in a DC to AC thyristor inverter. You can see this is an inverter circuit. What is the use of the feedback diode? These are the feedback diodes. These are used to freewheel the load current. Diode provide the path for load current when thyristors are off. So this is the right answer. Next question, it is saying for a diode, reverse recovery time is defined as time between the diode current becomes 0 and the instant reverse recovery current decays to which value? So we know that this is the reverse recovery characteristics and it will be the D option, 25% of IRM. IRM means reverse maximum current. So next question, a 100 microampere meter movement with internal resistance 300 ohm used in 0 to 100 milliampere ammeter. The value of employed shunt resistance in the meter will be. So from here you can calculate the N value or M value, N or you can say M value. M value is 100 milliampere divided by 100 microampere equal to, it will come as 1000. Now you can find the shunt value, shunt resistance value. We know that this is the formula. So the answer will be C option. Next question, it is given a CRO has time division control set to 2 microseconds per division, which displays the given below waveform on the screen. Then the frequency of signal will be. So if per division is this much, 2 microsecond, what is the frequency of the signal? So you can find the total time period for the one cycle. So it will come as 12 microsecond per cycle. If you want to find out the frequency, you have to inverse it. We know that f is equal to 1 by t. So if you inverse it, you will get 83.33 kilohertz. So B option is right answer. So next question, it has given a bridge and Z1, Z2, Z3, Z4 are given like this. So Z1, Z2, Z3 values are given, Z4 it is asking. So we know that Z1, Z4 equal to Z2, Z3. So if you put the values of all the values of Z here, So Z1 is 200 angle 30 degree into Z4 equal to Z2 how much? 150 angle 0 degree into 250 into or angle minus 40 degree. So here you can see that 150 into 250 angle minus 40 degree. So Z4 finally will become 150 into 250 divided by 200 minus 40 minus 30. So you will get this value. B option will be the right answer. Next question, it is saying for the triangular waveform given below, when given as input to RMS reading voltmeter, it will read. So it is asking what is the RMS value of this waveform. RMS means we have to first square it, then we have to calculate mean value, then we have to take the root over. So if you take the square and integrate it, it will give you the area. Then you have to calculate for one time period. Then you have to take the root over. So finally you will get a by root 3. So this is also a standard result also. RMS value of this waveform is a by root 3, where a is the amplitude. So let's see the next question. It is saying consider the following statements regarding faults in measurement system. The gross error in measurement. The gross error in measurement occurs due to fault of the person using the instrument. And it is saying the systematic error are present in measurement due to environmental effects on instrument. So both seems correct. So C option will be right answer. Next question, it has given parallel RLC circuit. R value this, L value is this, C value is this. If in the series connection new value of R is this and L value is this, what is the value of C for the same quality factor? So you have to find the quality factor first here. Q find Q value, then assume the Q value is same for the series connection also, then you have to find the C value in the series. So we know that for the parallel circuit Q is equal to R root over of C by L for the parallel circuit, and for the series circuit this is for parallel circuit QP you can say. For series circuit QS is equal to 1 by R root L by C. Just reverse of this, reverse it, you will get for the series. So if you put the values, all the values of RLC here, you will get QP equal to 1.58. Then if you assume QP value is same for series circuit also, then you can find C value for the series circuit. So finally we will get B option is the right answer. So next question, let's see, it has given the circuit as like this, and it is saying the equivalent resistance across the terminal AB is this. So here you can see 15 and 30 are in series, 12 and 3 in series, 6 and 24 in series. So if you rearrange it, it will come like this. Now you can calculate the equivalent resistance, it will come as the 23.18. So C option will be right. Next question, it has given two columns, we have to match it. So we know that del dot B is always 0. So A is 2 and B is del cross A is always B, so 2 1. So it seems first option is right, 2 1. So first option is the right answer. Next question, for breakaway point we calculate by this formula, dk by ds equal to 0, and angle of asymptote we calculate by this formula. So the C option will be right. Second 32 number question, to place the pole arbitrarily following condition must be satisfied. So this is saying about the state feedback control system. So it is saying which option is correct. So the correct option will be D option, state feedback and controllability. Controllability is the necessary condition for a system to place the pole arbitrarily. So it is saying if a system is completely controllable, its eigenvalues can be arbitrarily located by complete state feedback. Next question, it is saying lag lead compensator works as. The answer will be band reject filter. Lag lead compensator works as band reject filter. This is the plot of lag lead compensator, or can say band reject filter. So next question, it is saying which statement among the given is correct regarding conductivity of pure semiconductor material. So we know that the conductivity of pure semiconductor material rises exponentially with the temperature rise. So B option is the right answer. Next question, it is saying for a slip ring induction motor, if the rotor resistance is increased, then what? If R value, rotor resistance R2 value is increased, we know that the plot shifts to this direction. So the starting torque will increase, but the efficiency will decrease. So C option will be the right answer. Next question, it is saying when a transformer winding suffers a short circuit, the adjoining turns of the same winding experience which type of force? So we know that direction of current in adjoining turns is same. Adjoining turns in adjoining turns the direction of current is same. So it will feel force of attraction. Attractive force will be the right answer. Next question, it is asking which of the following statements are true with respect to interpoles in DC machines. First option, reduce armature reaction effect in interpolar region. So this is the interpolar region. Windings are connected in series with the armature, have the same dimension as main poles. You can see here, main poles are this and interpoles are this. So you can see dimensions are not same. So third option is the wrong option. So first and two only right. So A option is the right answer. Next question, it is saying the direction of current in compensating winding is dash to armature winding current, and which is responsible for having dash effect on armature reaction in DC machine. So we know that direction of current is opposite in compensating winding, and it has a demagnetizing effect on armature reactions. So the C option is right. So next question, it has given the following statements. First, it is saying surge impedance loading is also called steady state or ideal power transfer capability of transmission line. It is correct. The transmission line with reflection of voltage and current is called infinite line. It seems wrong because the transmission line with reflection of voltage and current without reflection, if reflection does not happen, then it is called infinite line. So the second option is wrong. In the third statement, it is saying the voltage at which corona is just initiated is called the critical disruptive voltage. So third statement is right. So the answer will be B option. Next question, it is saying maximum efficiency of modern coal-fired steam power plant is about 0.35 due to which reason? So efficiency of a steam power plant is low for which reason? The answer is D. High energy loss from turbine exhaust to condenser. Next, it has given the power system network containing 50 bus. So N is equal to 50. PV bus are 10. So M is equal to 10. 1 is slack bus and 55 are fixed shunt capacitor buses. Then the size of Jacobian matrix is. So we know that Jacobian matrix, the J matrix formula is 2n minus m minus 2 cross 2n minus 2, 2m minus m minus 2. So if we put the values of n and m here, you will get 88 cross 88. Next question, it is saying consider the faults given below: single line to ground fault, line to line fault, double line to ground fault, one conductor open, two conductor open. Which of the above given fault are shunt type faults? So we know that these are series type of fault and these are shunt type of fault. So the answer will be D option. Next question, it has given the circuit like this. Here it is the op-amp, then it is asking V output is equal to. So if you see here, ID equal to 0 minus of minus 10 divided by the resistance value equal to 20, which is equal to 0.5 ampere. So let's see the next question. So it is asking for what is the gray code for the number 7 in the decimal. So this is how we calculate the gray code also. You can see here the decimal number, here are the binary numbers, here are the gray codes. So the answer will be D option. Consider the following statement regarding static friction induction type wattmeter. So first statement, it is saying static friction occurs at disk which is not able to rotate when deflecting torque is small for low power load. Compensation for static friction is in the form of compensating torque produced by the shunt magnet. So both seems correct. So option C will be the right answer. Next question, it is saying digital frequency meter, the skimped trigger is used for. Skimped trigger is used for producing the rectangular pulse. So the answer A will be the option A will be the right answer. Next question, it has given the connection of capacitors as shown in the figure. So it is asking the effective capacitance between point A and B. So if you see here 6 and 6 are in parallel, so it will become 12, and it is series with 6 which is 4, and again which is parallel with 6, so finally it will be 10. So answer will be 10. Next question, it is saying for a fixed value of complex power flow in a transmission line having a sending end voltage this and real power loss is this. If sending end voltage is reduced to 50 volt, its real power loss is dash. So this is very important also. For fixed value of complex power, P is inversely proportional to V square. P is inversely proportional to V square when the complex power is fixed. So if you put here P1 by P2 equal to V2 by V1 whole square, you will get P2 equal to 800 kilowatt. So D option is the right answer. Next question, it is saying the number of flip-flops required by a mod 6 ring counter. So the answer will be 6. Next question, it is saying modulation is the process in which. So we know that modulation is a process of combining signals and radio frequency waves. So here the parameters of carrier signals are changed. So the B option is the right answer. So that's all for today. If you like it, give a thumbs up and don't forget to subscribe.